Good morning, I'm Dr. Huang. Today, I'm going to teach you how to use dimensional analysis method to solve stoichiometry problems. If you see a chemical equation in a problem, always use the chemical equation to organize the information. We put down 1.28 gram below carbon dioxide, because when you read the problem, you see 1.28 gram of carbon dioxide. We also put down a question mark, MOL, below Mn2O3, because when you read the problem, you see how many moles of Mn2O3. At this point, we are pretty sure this is a typical stoichiometry calculation problem, because for any stoichiometry calculation problem, you will be provided information about one chemical and you're looking for the information on another chemical. The information can be moles, can be grams, it can also be molarity, volume, density, or any quantity that can be related to moles. Now we are done for the first step. Step 2. Put down what you want to convert from on the far left of the paper. We want to convert 1.28 gram carbon dioxide into mole Mn2O3. According to the instruction in the flowchart, we need to put down 1.28 gram carbon dioxide on the far left of the paper. Step 3. Put down the unit we are looking for on the far right of the paper. We are looking for the mole Mn2O3. According to the instruction in the flowchart, we need to put down mole Mn2O3 on the far right of the paper. You may have already noticed I put down the chemical formula behind the unit. The reason I put down the chemical formula behind the unit is because grams of one chemical and grams of another chemical, they are not equal. Therefore, they cannot cancel. Also, the moles of one chemical and the moles of another chemical, they are different. They cannot cancel. If you write down the chemical formula behind the unit, we can avoid miscancellation. Step 4. Put down all possible conversion factors. All stoichiometry calculations need conversion factors from the balanced chemical equation. Since we want to convert gram carbon dioxide into mole Mn2O3, therefore we need conversion factors that include both. This is one conversion factor. This is the other conversion factor. The conversion factors from the chemical equation directly. The numerator, 7 mole Mn2O3, is from here. 7 mole Mn2O3. The denominator, 5 mole carbon dioxide, is from here. 5 mole carbon dioxide. I put down MOL between the number and the chemical formula. This will remind us this is the mole ratio, not the gram ratio. If we flip the numerator and the denominator, we get the twin conversion factor. We want to convert gram into mole, but the conversion factor from the chemical equation can only allow us to convert from the moles to moles. Therefore, we need a conversion factor to convert grams into moles, which is the molar mass of carbon dioxide. To calculate the molar mass of carbon dioxide or any chemical, it can be very easy. all you need to do is to look up the periodic table for carbon, which is 12.01. Multiply the number of carbon atoms in the molecule, which is 1, plus the atomic mass or the atomic weight of oxygen. This number is from the periodic table as well. Multiply the number of oxygen atoms in the formula. Then we punch all the numbers into a calculator. The answer is 44.01. This number tells us 3 different things. First, it tells us for every 1 mole carbon dioxide molecules, the mass is 44.01 grams. It also means if you have 6.02 times 10 to the 23rd carbon dioxide molecules, the mass is 44.01 gram. This number is Avogadro's number. It also tells us for every molecule of carbon dioxide, the mass is 44.01 atomic mass unit. Because we want to convert gram into moles, so we need conversion factors from the first equal relationship. This is one conversion factor. This is the other conversion factor. Step 5. Pick a conversion factor and multiply what is on the left side of the paper. We want to cancel gram carbon dioxide. So we need a conversion factor that has gram of carbon dioxide in the denominator. So this one should work. Can the unit cancel? Gram carbon dioxide as the numerator, gram of carbon dioxide as the denominator. They will cancel according to mathematical rules. Do we get the desired unit? The unit we have left is mole carbon dioxide, and the unit we are looking for is mole of Mn2O3. The answer is no. We go back to step 5. Pick a conversion factor and multiply what is on the left side of the paper. We want to cancel mole carbon dioxide, so we need a conversion factor that has mole carbon dioxide as the denominator. This one should work. Can the unit cancel? Mole carbon dioxide and mole carbon dioxide. They should cancel because one is on the numerator and one is at the denominator. Do we get the desired unit? The unit we have left is mole Mn2O3. The unit we are looking for is mole Mn2O3. Bingo, well done. We need to punch all the numbers into a calculator. Then let's see what we can get. 1.28 multiply 1 divide 44.01 multiply 7 divided by 5. From the calculator, the answer is 0.0509. To avoid any penalty, you need to put down everything on this page.